Day. Okay, we are now recording. So welcome to our EDM program discussion for December. So last we talked was September. I guess we're going to keep these kind of roughly at the same frequency as IETF unless we want more, but they're offset because we live in a virtual world where nothing aligns and nothing needs to align anymore. Welcome to 2020s. All right, so for today, I wanted to focus on specifically some kind of broader thoughts that we have around extensibility and evolvability, particularly going off of some of the ideas in the use or lose it draft. So kind of anything in here that we think about, I think is fair game to discuss. But I kind of want to focus on some of the conceptual directions we want to take the document and the discussions, more so than just like editorial nits. And I had sent out a couple issues that we filed on the EDM program list just for kind of starter topics. And I guess unless someone has another suggestion, we can just kind of go in that order. And I think this is a small enough group that we can just kind of have a pretty open discussion. If you want to get a word in and it doesn't seem like there's a good time, you can always drop something in the chat, like a Q+, and I'll make sure that get to you that way. But other than that, I think we can just kind of have a nice roundtable discussion. So the first thing that I brought up on the list was something that was relatively early on in the document, kind of talking about version negotiation and what makes that successful or not. So here's the issue kind of topic that I filed here, and Martin already commented a bit on it. What the document says right here is commenting on some of the bits of RFC 6709 that talked about suggestions for how you do version negotiation, how do you make it simple, but then pointing out how this in practice actually doesn't work. That active use is still very important. One of the other things I was thinking about kind of as we look at this is a lot of the examples of how we end up doing version negotiation seem to be about putting that negotiation in some other layer in the same way that we have ALPN and TLS determining version negotiation of HTTP. Practically, when we're doing stuff between v4 and v6, we use the Ethernet frame types as opposed to actually using the thing embedded in itself. So like, since version negotiation is like a pretty fraught thing to make sure we have active use, at least in what we've done so far, it seems putting that version negotiation in some other protocol's extension ends up being something that has worked. So yeah, oh, here we go. So I'm curious, what do people think about that? Are there any conclusions that we can draw, or how do we pull on this thread?
So I think one of the interesting things here is that you've essentially identified another example of why the core thesis holds true. And that is, I think, I'm reading Carsten's comment as well, along similar lines to what Carsten's talking about. And in that, when you have a single protocol, and the only way for that protocol to be upgraded to version 2 of that protocol is some previously untested mechanism within the protocol, then you end up with this, well, I don't know if it's going to work when the time comes. And so we have that problem with a bunch of protocols. And I think you've just identified a really good example of how to apply that. So maybe we can just expand on that a little bit and talk about how that was the case.
Mhm.
I mean, I don't feel like the cuts you're drawing here, I don't think are necessarily the cuts between um but between version negotiation mechanisms work and ones which don't. It's ones which are prepared to have. I mean, protocols have in-band negotiation for compatible versioning and ones which do not, right? So I mean, the ALPN like is a good example where you didn't want to have to spit out an HTTP 1.1 request in order to get spun up on H2. And so I think that the two scenarios in which I see, which you typically don't have, and which you typically want out of band negotiation, are ones where it's non-interactive, as with IP, or where you're trying to reduce round trips, as with LPN.
Okay, so I mean, do we think that the main reason that we use that for H2 versus H1 was to reduce the round trips?
Yeah.
Yeah, that was the primary motivation. Yes.
Okay. Yeah.
No,
Okay,
I think they go hand in hand.
It's very easy to just cut over though, and not have to worry about them being mutually intelligible.
Well, no. How would that have worked?
Right. Yeah, I mean that would have been. I mean,
You had to spit it out. You had to open up with it. I mean, you had to do 17 upgrade, right?
Yes.
So I think this is going hand in hand. The reason that we did this for H2 was to get the performance benefit. But one of the consequences of choosing that particular design was that we started to rely on a mechanism that was essentially pretty well tested and already proven. So I think that's reasonable. The IP one is far more interesting in that regard, I think, because IP version 4 has a version number field in it.
Yes.
And they tried to deploy it with, a 6 in that field, and it no worky. So
Exactly.
yeah.
How much of the
Why didn't it? That needs unpacked.
right?
Yeah.
I don't think it didn't work if people wouldn't accept the 6.
Well, yeah, people didn't accept the 6 because it effectively the network had ossified in some way.
I mean, I don't think
they were expecting 4 in that spot and rejected anything that wasn't 4. I don't know the details.
I'm not persuaded that's the primary reason for the failure of IPv6 to deploy fast.
Well, it wasn't just that it wasn't just that they were expecting the 4 to be there. It was expecting they were expecting all of the other bits of that header to be in the places that they expected them to be in that header, including and up to the middle boxes that were having trouble with this. We're also expecting the first 4 bytes of the thing after the IP header to be port numbers no matter what. Right?
Wait a second. Like if you're a middle box, unless you're a transparent middle box that has no addressing, either you speak v6 or you do not. And if you do not speak v6, then no one behind you can speak v6. And if you do speak v6, then it should work. So I'm not buying this argument.
Right. So, but it's less about, okay, so the behavior of saying, here is a version that I don't understand, right? Like, so this is another problem with version negotiation mechanisms in general, is that you either, if you have something that's trying to participate in the conversation, that is trying to use the wire image, it has 2 things that it can do with a version it doesn't understand. It can either pass it forward, say, I don't understand this, so I'm not going to mess with it. Cool. Or it can say, I don't understand this, therefore I can't perform my function. And of course, the world is better with my function than it is without it, so I'm not going to pass the traffic. I think the problem with, and actually we should probably get someone in here who actually was around when this.
But you're saying pass the traffic. Like right. if you're a visible endpoint of the wire.
Right.
Which
then pass the traffic is up the stack. Right.
Not just that, but either you have a v6 address or you do not. And if you don't have a v6 address, then you don't have a v6 network. And so it's not a matter of there's an interop. It's a matter of it actually had to participate in the system. Like the way IP routing works is the routers have IP addresses, and so.
Right. So, but the problem that we're talking about here is the fact that a v4 packet or a v6 packet or a v whatever, an IP packet, encapsulated in ether type 8600, is it? And it's 86FF. It's been a while. The 8600 mint IP, you look at the version Like that was what it was supposed to mean. Look at the version to figure out what you're going to do with the header. And what everyone did was look at the ether type and said, this must be an IPv4 header.
No, I understand what you're saying, but I guess my point is, well, how could it have behaved differently? Like, say that were not the case.
Okay,
right?
yeah, fair enough. Yes, right. Yeah, so how could it behave differently if it's using 8600 but doesn't know IPv6?
Yeah.
Yeah, then it's not going to pass the packet. Yeah, good point. Okay.
Sure. But I guess it's like this was probably something that we should kind of unearth the history for, to do a little report on it. But I mean, you reasonably could have used the old ether type and then expected software that is able to, like when you upgrade your router to have v6, look at the version type.
Right.
It kind of similar to how, ALPN gives an opportunity to load in a different stack to essentially redirect to a different piece of software or a different portion of software. It's very convenient to have, we read out the Ethernet type and we just shunt it off over to an entirely different part of the stack rather than having a legacy stack that knows about v4 have to be upgraded.
Sure. So I'm wondering if the thing we learned from the experience with ALPN and v6 and ether type is that you can't do in-band version negotiation without the assistance of the layer underneath you. And if you don't have a layer underneath you, then the right thing to do is invent one.
I sort of wonder how much of this is to do with there being a parallel fallback you can do for the ALPN case, but not for the
v6
case.
Can you explain that a bit more, Colin?
In the web case, there's almost always a 1.1 versus a HTTP 1.1 versus a 2 fallback. So if it doesn't work, there's something you can immediately try. For v6, it's not obviously clear what the fallback is in a lot of cases, because the whole point of it is to get devices which can't have a v4 address, or a routable v4 address. So how do you fall back, which makes negotiation different?
But LPN doesn't really depend on fallback, right? I mean, in fact, the point of ALPN is to determine that that when you have an HTTPS URI, that the server you're talking to is H2 capable without probing it. I mean, you say it's a fallback, but what it is,
but there's an alternative that exists at the time, and that's not it's not obvious what that alternative is for a v6 packet or a v4 packet in v6.
Right.
I think now we're talking about the virtues of hard cutovers versus negotiated ones. Yeah.
Yeah, that's exactly right.
Successive negotiation, I suspect.
And it seems that, a lot of these examples of doing out of band version negotiation are, they're also tied to a hard cutover, which also seems to work better. Like and in the original bit of the document, actually, if I switch over to this issue, you point out, for example, SNMP, like these cases of hard failures and hard cutovers often kind of make it easier because you don't have to worry about this middle space where you just have incompatibility or bugs because you're trying to do a version negotiation in band, but something's not going quite right. No. Let's see. And you just a bunch of stuff in the chat. Do you want to mention something?
I don't think there was a whole lot to talk about there.
Okay.
Just some counterfactual hypotheticals.
Yeah, the hypotheticals are fun. I just saw, Tommy, that you flipped across to the other issue that you have there, which is an example of version negotiation that I believe was successful, but was in band, which is a curious one to perhaps dig into a little bit.
Do you want to kind of summarize it for people?
Yeah, so my understanding is that SNMP version 2 had very clear rules about what to do with packets that didn't have the right version number in them. And maybe it was luck, but implementations followed those rules because they were pretty simple. If you get the packet, drop it. And that meant that it was possible to deploy new versions relatively easily. And so maybe one of the things we need to think about is whether in those cases that you do have version negotiation capabilities, it's as simple as possible. But I don't know.
So I guess the SNMP case is sort of interesting to me in that the difference between the protocols is perhaps not like hugely security relevant. Like if you're negotiating between TLS 1.2 and 1.3, like you kind of care if you can get 1.3 and you want to super reliably get that. Like same for if you're doing quick or H3 versus H2. But for SNMP, like, is it maybe that you can get more data with the newer version, but you don't fundamentally care if you get stuck on the older version?
Yeah, that's actually an interesting point. My understanding was that the upgrade to version 3 was not universally successful in the sense that everyone suddenly adopted it and started using it. There was a lot of version 2C, whatever, for a long time.
And when we talk about the hard kind of failure there, was it the kind of scenario in which one side would say, okay, I want to speak version 2, and if the peer only does version 1, that just fails, and then if you want to do version 1, you need to kind of retry with version 1?
Yeah, I don't know about version 1 specifically, but yes, that's essentially what would happen, is that the clients would essentially send whatever version they preferred, and if that didn't work out, then they would try the other one.
Yeah. Okay. So no intention of doing any kind of graceful negotiation over. Yeah.
I think it may have also been the case that a lot of systems would have the version number of the protocol configured.
Yeah.
So you wouldn't even have to do the probing.
Right. I mean, if you're doing your automated monitoring, you just sort of know what you're going to talk, and you deploy the new config when you've got the new software, and you have a little bit of interactive use if you're trying to debug something, but trying the new thing and then trying the old thing while you're debugging is not a huge problem.
Right. And arguably then, if really it's a matter of configuration and expectation, then it's really just like the other out-of-band mechanisms. Sure, it's not an ALPN or some lower level protocol. It's just completely out of band. But that's really what makes it work in a way. And maybe that's why it was a good example of success.
So Tommy actually said on the mic what we were saying in the chat: version negotiation via Yang.
Yeah, no, exactly. Right. I mean, that works if everyone can agree. Yeah.
In a single management plane, yeah, boom, done, simple.
Well, that's what the service B thing is trying to solve for us, right? Shove it in DNS.
Right. Okay, that works. Put it in DNS and close the program.
Brilliant. Love it. Yeah, I mean, so to some degree, let me go back to this. Right. Like, how much is in-band version negotiation, bad to do? And kind of what this issue I'm trying to explore here is, what type of kind of extensibility or extension mechanism is right for different cases. And I guess when you do have a mutually kind of intelligible protocol that you could do some type of in-band negotiation, when would it actually make sense to do version versus just adding extensions? And this is similar to some of the discussions we're having right now in HTTP, as we're trying to do a BIS of H2, and people bring up, oh, should we just do a new ALPN? And that's an example of saying, should we just rev versions to avoid kind of cruft or ossification or bad behavior we didn't like in certain deployments, even if it could be otherwise a very intelligible protocol.
So I wonder whether it might be interesting to look at the success of deprecation of versions versus the success of deprecation of extensions. Because my first impression here, and it's not motivated by any data at all. This is just sort of like me arguing from first principles at 11 p.m. is that an extension mechanism where you're negotiating an extension in a protocol, it's very easy to add it and relatively difficult to take it away. Like you get this problem, like, so for example, with cipher suites, it took a long time to get rid of bad cipher suites because you had to make sure that all of the implementations that might be, or that both implementations were not going to try to negotiate it, right? And there was always a little bit of fear of getting rid of it because you're going to trade off insecurity for connectivity. Whereas with a hard failure, hard version change, that gives you an opportunity to actually deprecate functionality at that version change, where it's never in the new version, right? Like, so you use extensions to add and then version numbers to take away.
Okay, I like
It
that.
seems like, but I would actually want to look at the history of these things to know whether that dynamic actually shows up in organizations other than my day job. Let's put it that way.
Right.
Yeah. So Carlson points out that you can negotiate features that take stuff away, and I've seen some cases where that's been successful.
Okay.
We did that in HTTP2 with cipher suites, if you'll remember.
Yeah.
There's a really long appendix. And that was one of the rockiest parts of the deployment of H2, I've got to say. Maybe because that was the nature of the way that we did it, but it was pretty rough.
Yeah, it was a layering violation that people had trouble wiring through because you don't know if you're going to do H2 until you do the LPN, but you've already done the cipher negotiation. It's pretty messy.
Yeah.
Mm-hmm.
But now people just don't use those cipher suites anymore, and everything's great.
Yeah.
Right, but do people not use those cipher suites because of the deployment and implementation of them, or do they not use the cipher suites because of the PR campaign about these are bad cipher suites? Right, like, so there were technical changes and there were then non-technical changes that made that deployment happen, right?
Hard to know which one drove which.
Right, exactly.
But certainly for those people who are deploying H2, it was very easy.
Mm-hmm.
Right. Okay. Point.
Yeah. So just as a thought experiment, looking at some of the discussions we're having right now, as we are doing this of H2, let's say there's a feature you want to get rid of. Like this is not the case, but let's say everyone decided like we hate push so much that we should just make it not possible to do, and that we don't want any H2 push, and we would have the option of saying, okay, rev an ALPN, rev a version so that you're guaranteed you never have this, or you say, have some sort of negotiation. Is this the settings or some other, whatever extension mechanism you have to say, I don't want this, I don't want to be able to support this feature. And we do, as I'm pointing out here, like there is the option of saying that you have an extension that a client or any endpoint in this can fail hard if they don't negotiate it. Say that I don't necessarily need to rev a version in order to fail hard if the principle that I want is just I fail hard if this thing is present. And so do we think those things are decouplable? Maybe that was not very clear.
That's the sound of hard thought. I can't. I mean, yeah, no, I'm going to mute again and think hard about it. So, like, I'm always a little bit twitchy about fast fail or hard fail as a mechanism that you use in every environment, right? Like, so the environments that most of us work in most of the time these days, there's enough continuous integration and testing, and like the point of hard fail is that you make sure it fails very early in the deployment or even very early in the development, right? Like you want to make sure that it's not going to work. There are deployment patterns where that's like you basically end up trading off. I mean, this is back to the whole the Postle's principle argument, right? And I don't think you can disconnect this discussion from that discussion, where and they're like, there it's very easy to have very long arguments from first principles, and very difficult to figure out what the actual impact of sort of the way that we would do this in a continuous integration environment would tend to work in certain embedded environments. And then like the flip side of that was then maybe you should use the lack of connectivity or the complete ossification as a lever to get better engineering practices into other fields, which is also a possibility. So I mean, like I'm not sure how to like constructively talk about that. I know how to unconstructively talk about it. We've done quite a lot of that.
I find it interesting, just how you're bringing up kind of the continuous integration model and kind of that continual evolving, because I think, again, not entirely formulated, but that's something kind of underneath that, the various thoughts I'm having here and what I'm trying to get to, that we could have a model in which you have hard version changes, and these things are probably necessary for things that are not going to be at all intelligible across versions. But the other way of thinking of a version is just like, this is a snapshot of a protocol that has support for these particular feature extensions. And like there could be a snapshot of H2 that got rid of push and added the new priorities extension, but other than that is totally intelligible. And we could call it a new version, or we could just call it, like a snapshot of extensions. And if you viewed almost like the protocol itself as some, kind of continuous integration, which things are coming and going, I almost want to be able to say, just kind of here's the snapshot, here's the minimum snapshot that I require, or here are the different snapshots I'm compatible with. And if you're older than this, snapshot, if you're 10 snapshots back,
right,
I can't speak that. But
so that works really, really well in a web-like environment, right? Like, so in for browsers, right? The browser is going to get launched, once per session if the device is being used at all. I'm wondering if, so the way that you would recover from, like, let's say, big shiny future, we actually have continuous integration all the way up and down the stack. We are rolling out new versions of IP biweekly, because we softwareified everything. And we have a build horizon of these that's like 6 months back, right? Like, so we're doing what is that, 25, like 12 versions are running simultaneously.
Right.
And anything older than version -12 is dunk it, right?
yeah,
What you need in that situation is a bootloader protocol, right? Like, so let's say that I, went on a really long vacation. or was in quarantine or whatever reason you'd be offline for 6 months, and you boot your device and boom, you can't even speak IP anymore, right? Like Ethernet's probably about the same because we're not shipping a new set of switches to your house every 2 weeks, but everything else has changed. How do you get back to a state where you can have connectivity, right? And this seems seems ridiculous to those of us who like don't work in kind of like gigantic monorepo single production environments like some of us do or have. But if you just change the timescales, it's exactly what you run into with sort of embedded development, or exactly what you'd run into if V6 managed to actually deploy and replace V4.
Right.
So what do you do in that case? And I think what you do is you look at like these devices also generally have sort of like two modes, one where they're running the actual software, the actual stack, and one where they're running just enough of the stack that never changes to reload the stack.
Right.
Right.
Every protocol can have like, here's its baseline version that
right.
Like essentially, or for this version, you always support the baseline, and then you can support whatever combination of extensions that are snapshotted and whatever in the future.
I mean,
as long as you always fall back.
So one difficult part with this view is how do you arrange that you get the highest common version as opposed to the attacker decided version?
Right.
And this has been a problem with essentially one of the reasons to have like specific version negotiation as you try to keep working is to be able to make guarantees about what is happening here and what the properties the version negotiation itself provides. There's a number of papers on this recently. Probably the best one being by Green and Bargavon and some others on TLS. But it's like incredibly hard actually to make guarantees about like what the version properties are, and especially in hard fail circumstances.
Yeah. I mean, so what normally, like, what is our state of the art approach to making sure that someone just can't force you down, other than just say, I don't support those old versions anymore?
That doesn't work because you have to say that securely, unless you're saying it Yang, I guess. Like the way it works in TLS and the way it theoretically works in Quick is that the version, the mechanism which is used for version negotiation gets eventually folded into the transcript that is used for the cryptographic establishment. And so as long as the version you eventually negotiate has strong integrity for the transcript, then it theoretically retroactively blesses the entire version negotiation.
Yeah, but that also means that the weakest authentication scheme that you support determines the strength of your version negotiation authentication.
Yeah, so as far as I know, there's no technical way to avoid that.
Yep.
Yeah.
Yeah.
So what are things have?
Yeah, please.
Oh, go ahead.
Well, I was just going to comment, like, does that hold true for, like, when we're talking about versions, like, let's say within TLS, because I'm doing HTTP, I'm doing some application within that. Or is this really a property of kind of the security protocols that are more exposed to the open networks?
What do you mean?
I think what Tommy's asking is, do we need to worry about this so much when it comes to protocols that use things like TLS, or is this exclusively a problem for things like TLS where they have the security exposure?
Well, I think it's potentially a problem. I mean, there's an internet graph by some guy Martin Thompson about like what happens when you have when you have two different protocols, one of which speaks to TLS handshake but with different networking properties, and having sure you don't get forced down from one to the other. Right. So I think it is. I think the solution you adopted is exactly the solution I'm talking about, which is to fold the version negotiation effectively into the transcript.
Yeah, it's the best solution we know about.
Mm-hmm, mm-hmm.
So I want to sort of maybe roll this back to the original thing, because I think that Tommy's identified something's really interesting here from the perspective of the draft that I wrote and the work that's going on there, and that is that version negotiation is a particular example of something that requires extra attention, and we don't really provide any advice on that. And you've identified one pattern that I think can work in a number of contexts, and that's this hoist your version negotiation outside of the protocol to a layer that has the properties the rest of the properties that are being espoused in the draft.
Mm-hmm.
And I think that's worth calling out in detail, because version negotiation is such a tricky and thorny thing to get right.
Yeah, that makes sense, and I'm glad that you kind of agree, because when I was reading kind of the beginning of the document, let's say going through section 2, it feels like, you know, there's quite a bit about version negotiation, but we don't kind of come back to it in terms of our analysis or the principles, and it feels like there is room for that. And you know, bumping up a level to kind of more meta questions on the document. It feels like it would be useful to also kind of segment out the analysis and advice based on kind of what layer some of this is happening at. Like, you know, I think some of the mindset in it is, it feels like, you know, okay, this is kind of what we're thinking about for TLS and Quick and HTTP. But calling out some of the distinctions about, we were just saying, like, am I the protocol that's directly exposed before encryption? Am I kind of within, am I folded into the security handshake or after it? Am I talking about how I'm negotiating my version to begin with, or how I'm doing an extension within that? And I think we have kind of different approaches that work better or worse in different scenarios. And particularly, like, certain approaches, you know, are a lot easier when you don't have to worry about middle boxes looking at things versus when they are, and different types of ossification come up when you have middle boxes versus not. Yeah. There's one comment. Just going back, I'd been looking at the chat, which I'll copy off and look at later more too. One comment a while ago, I think that Mira, you made about how many extension mechanisms do you need in protocol to be on the safe side? I'd be curious to hear what you're thinking about that, because one of the things I take away from this document is almost just saying you want very few extension mechanisms, but just have, you know, essentially like as few as you can, but use them over and over again as much as you can.
Yeah, I think that one pattern that seems to have been successful is to effectively say, I'm not actually going to change the version number of the base protocol. I'm just going to do a bunch of stuff with extensions and negotiate the individual features I want. And if I do end up needing to make a drastic change, I'm going to do the negotiation at a lower level.
Right.
So, yeah, I think that's a TCP model, and that also has failed in some cases, right? And in TCP, we're a little bit stuck because we only have this one extension mechanism. I mean, there are like 2 more bits left, whatever, but nobody wants to touch them. And in principle, because we've been talking about kind of a little bit the difference between versioning and extension mechanisms, and I don't think there is actually a difference in the sense that you can both use to, you know, extend basically everything. But there's probably one difference that Brian mentioned is like a version should always be a bigger change. So it's a little bit of reset or something like that. But even in Quick, where we want to be much more flexible about versioning, we now have like a bunch of extension mechanisms because we use them for different things. So I wonder what the right advice is there.
Well, I think one important difference between versioning and extensions is the extensions are orthogonal in many cases. So, I mean, so like versioning is linear, right? But you know, it's perfectly possible to have, you know, to have a quick implementation which has datagram, but doesn't do, I don't know, like doesn't do some new extension which you know, combined acts, I think was what we were talking about with extra timestamps, and or vice versa, right? But in Sure, Ben. Yeah, it's not whether or not, but versioning is never orthogonal, right? And it's also not orthogonal. It's not subsettable, right? That, either you do, either version 7 or you don't. But you can't say, you can't offer you can't offer I do version 6, 7, and 9, and have the other guy say, well, I'll do half of 6 and half of 7. That's not possible, right?
So I think that's not true. It's just the way you design it. Like instead of doing half of 6 and half of 7, you just have to define a new version number, whatever, 11 or where you are.
That
and
falls apart incredibly quickly. Like as soon as you have like more than 6 extensions, it's a disaster, right?
I know. Is it so much different to have one extension point and use this heavily, or have like 3 different extension points that you use less? I think from a functional point of view, you can realize everything with one extension mechanism if you really want to.
I'm not saying that. What I'm saying is that's different from versioning, where versioning is where it's one. So like imagine you have a system like TLS or Quick for that matter, where you have you can offer an arbitrary number of extensions. The other side can subset them. Doing that with a version number requires defining the common total explosion of all possible extension points, which is not practical.
Well, so I mean, if you wanted to have a version that described each possible combination of all defined extensions, then yes, it does explode. However, I mean, you could have a model in which you just take the extensions kind of linearly and not say that I necessarily support or implement all of them, but at least I know about all of them, and all of the kind of defined extensions up to this point won't break me. Or I behave correctly with them.
I mean, sure, you could do that, but that would require a very different kind of protocol design from the a la carte systems we have now, right? Where so like again, just go back to TLS. In theory, you're supposed to not choke when anybody offers you any extension whatsoever, right? But that doesn't mean you have to take the extension. And so I don't know about extension 1, 2, 3, 4, 5, 6, but like I've got to be something to the other side. I am going to do it, or I'm not going to do it, and that requires more than just that requires a mechanism.
Right. Well, so this is kind of jumping a little bit into the greasing and coordination topics, but some of the proposals around for greasing, if we want to do so coordination for greasing, is saying like, okay, we have all the different implementations or a subset of implementations kind of agree on these are the random values we're going to have. And doing that, or doing greasing with random values, brings up the concern about, am I going to end up stomping on actually legitimate extension values or things that people are using in practice? And the coordination is one potential way to make sure that you are not doing that. If you had a mechanism which you kind of had this rolling version snapshot that said, this is, I know about all the extensions up to this point. This is as far as I know. Anything I don't recognize after this, I will treat as if it's greasing. Is kind of another way of just like doing that coordination. So if we're going to go down the road of having greasing,
just compression though, isn't it? That's just compression though, right? So if you said that version TLS version 1.4 was TLS 1.3 with the following set of fixed extensions, that's just compression, really. It's not.
Yeah, I mean, to some extent, if you make an analogy to the single joint that's a version and you have this combinatoric explosion thing, that type of compression lets you cut off parts of the space of the combinatoric explosion.
Yep,
doing similar
that's
stuff.
right.
Yeah, that is a good way to look at it. Chat.
I kind of think we could probably talk about this topic forever. Are there any other things that we would like to talk about?
Looking at the chat, the last comment in the chat, minimal set of substrates. Does that get easier as the network gets more mature and we get more bandwidth? We're not trying to optimize things quite as furiously.
We're still trying to optimize a lot of, like, you still want latency to be low, right? And you don't necessarily want to use bandwidth the same way we use compute, such that like everyone's computer has a it's exactly as slow as your micro from 1982.
We're not optimizing quite as much as we used to for bandwidth.
Right. And you don't need to optimize for that's actually really interesting. We're still optimizing for latency because latency you can't build your way out of. That's an interesting insight.
I suspect that the balance has changed a little bit over the years, but I'm still seeing a lot of people trying to cut down on the number of bytes, particularly when it comes to things like real-time media and that sort of thing. Because one of the things that I often try to push back on is, why are you not using a 16-byte authentication tag for your encryption? And they're like, but it's too much overhead. I want a 4-byte authentication tag, even though I know that's terrible. And so that's where we're at still.
Right. Okay. Well, so how much of that is people actually trying to meet a performance requirement they know they have, and how much of that is just the fact that we've educated a generation or two of network engineers who are really good at bit shading, because that's how you pass the exams, right?
There's also the fact that you have the people working on this are also the same people who develop codecs. And when you develop a codec, you're talking about sub-bits, right?
When you develop a codec, you're talking about sub-bits, and we're happy about that. That's what actually allows us to waste bits in the network, right? And if you're talking about a codec that's getting the maximum amount of like useful information into certain constant size packets, and maybe you're making those packet sizes bigger, right? So you can amortize your overhead a little bit that way. Then you can actually, use your overhead. This is a thing that you can spend overhead on, right? Is the flexibility and the evolvability of the stack. Like, I mean, the problem is that you for this minimal substrate thing, you'd either have to identify the set of minimal substrates that are already deployed, or you have to say we're going to wait 20 years for it to happen, right? Because that's about how long it takes to forklift the internet. So what are the minimal substrates that are already deployed? So RPCs now are JSON on H2, or possibly JSON on H3. You can build you build everything on that, right? You need some streaming stuff. Right.
But that really just speaks to the value that's provided by things that have high use again. Right. So the things that people care about are the things that continue to work. And so if you can build on top of those things, then you don't have to worry about solving all the problems that have been solved by the fact that there's an enormous force pushing behind it.
Right. I mean, that's
also like if there's something that you want to work and you care about, but you are not, let's say, large enough to be that whole force, just use make your thing an extension of the existing thing, such that you get the benefit of that large force rather than trying to go off and make your own IP protocol.
And that's the central thesis here anyway, right?
Yeah, I think there's sort of a recurring trend of, we don't want to just make it easy to do the right thing. We need to make it so that you have to do the right thing in order for it to work at all. And that comes up in several different guises in terms of, if we're going to use TLS extensions to be the version negotiation, like you have to implement TLS extensions. And we don't quite succeed in that you don't have to implement extensions exactly right in order to get your version negotiation functionality, but you have to do something with it. And we can do that a lot with the crypto as well, in that, if we're rolling some of these protocol elements into the actual keys that you derive, if you do it wrong, you don't work at all because you have the wrong keys.
That was a nice innovation in TLS, I think. is where we started to do things like, well, we're not going to put that on the wire, but we're going to authenticate it by virtue of rolling it into the keys. And that worked out pretty well, I think.
Yeah.
Which may be worth a call out in here. I feel like it's kind of like related to your point about, getting dependency into things, but it'd be worth having with it.
Yeah. I might try to find examples of that one. The retry mechanism in Quick is one example that I think works for that.
Yeah, that's true. Very good.
What I found interesting about this document is really kind of the relationship between greasing and invariance.
Mhm.
Because kind of everything that you don't use, that you don't grease, will sooner or later become an invariant. Will be, especially if you expose it, it will be part of the wire image, and people will just like treat it as an invariant. So kind of the opposite definition of everything that's not invariant has to be somehow flexible, used, and changed over time. That was kind of a takeaway for me when I read an early version of the document. Not sure if I read the latest one.
Yeah, I actually filed an issue during the call that was sort of asking, do we have a case that we can point to where just writing down the invariance is enough to, by implication, say that everything else is subject to change? Or do we actually get stuck in this case where even if you document the invariance, you have to grease or exercise everything else in order for it to still work?
Yeah, and I suspect that we're in the middle of the grand experiment in that one. I don't have anything.
I also said I don't think we've been documenting the invariance for long enough to really have good data.
Right.
But I think this is if we want to kind of make sure people understand that, then I would even like to see this much more prominent at the beginning of the document.
I agree. That's kind of getting to the editorial comments, but it'd be interesting to look at ways to highlight some of these earlier, because I feel like some of the greasing and invariance bits we just kind of like fall into. One other thing I note that's not covered in the document, because I don't think it was discussed as much at that point. Now when we're talking about greasing, there is more discussion about coordinating greasing, and that's not discussed at all. How do we think that would kind of fit in, or is that a little bit too nascent to be able to say too much about?
So I don't know if this is exactly what you were going for, but I think one of the general challenges with greasing is that you have to be very careful about what you're doing if you can't place a time bound on it. But if you can say, I'm going to try this and I can guarantee that it will not be used anymore in 6 weeks or 6 months, then you have a fair bit of flexibility about what you can do.
Or I think a time bound, or a like a version bound, or what we were saying, that if you had continuous integration versions, like there are other ways to kind of cut off the harm, but you need a bound on it if you want to be able to reclaim the space.
Right. And like we get this coming up, Ayanna was asking, do you really, so we have this 4 billion code point registry. Do you really want us to put every 20th value in there as reserved?
Yes.
Yes, we are totally trolling you, Ayanna. Yeah.
So Mike Bishop worked out that on his home internet connection, it would take, I think it was 10 millennia to download the registry page, if that was the case.
Well, so we just need to get to the state where bandwidth is like compute. Everybody's got a 40 gig NIC.
Yeah.
That wouldn't help that much.
This is why we have a bandwidth problem. Like, this is the thing that's going to push our
Exactly.
application ahead. It's being able to download the registry. Colin, were you going to say something earlier?
I was going to say, do we need to coordinate the greasing points, or do we just need to make them mutually ununderstandable so it doesn't matter if you clash?
Right. That's
Tommy's idea, isn't it?
Yeah.
I actually don't think that the future here is in greasing. I think the future here is in the big actors in the space coordinating and using features in such a way that people routinely encounter new code points. Whether or not they correspond to real new features or not, they keep discovering them. And that might just be down to, okay, so in the month of January 2021, everyone's going to be sending the TLS extension code point 57, and at the end of the month, they'll stop.
yeah. I'd
So
like. Yeah. Go for it, Brian.
you could actually do that with a registry that was easier to download than, you know, a 10 Millennium registry, right? Like you can have a. I know that the word key schedule means something different, but it's basically a key schedule, right? So, you know, go to this. The semantics of go to this website and figure out that you're going to send this on this date is enough, right? To make sure that that gets exercised. Because they don't have to be secret.
I also think it's worth asking if we're just over-indexing on this. Like there have been a couple of high-profile cases of old pieces of software which handle this very badly, but my impression is that like most of those systems, like the people who work on those systems, learn the lesson and do tests for those things. And so, like, that's not saying nobody ever makes these mistakes again, but that like it'd be interesting to see, like, you know, whether we really find that like that this implementation handled this as badly as people had in the past. And there are like lots of mistakes people used to make, like, you know, like in engineering that like are harder to make now and people don't make them as much. You know, so I mean, I'm not saying I think it's an open question both how well greasing will work and how necessary it's going to try to be.
Yeah,
Good.
I mean, I also tried to make this comment in my mail earlier that I think I agree with Martin that like active use should be the goal here, right? Greasing is just the hack if you can't do active use. And also we have been using greasing successfully in cases where there has been ossification and we just needed to detect the broken systems. But we haven't used greasing successfully, or we haven't tried it, or we haven't had much experience with like putting it in a brand new protocol, and it feels really still like a hack to me, and somehow a little bit wasting our valuable bits. If we can't design a protocol that it can be active use, then maybe that was wrong.
And I think the question, we're at the end of time, so we can, you know, leave it on this thought is, yeah, I'd be interested to see, you know, if we are designing a new protocol and we have a greenfield, is there a way to set things up to have a dependency on the active use such that you don't need greasing in the same way, or, you know, the properties that you get from greasing and active use can be folded in, and we don't end up in a scenario in which 5 years after you release that protocol, you have to toss in some extra grease to get it unossified. So that'd be good. All right, thank you everyone for the time. This is recorded and we'll have that uploaded, and I'll go through and do the notes for everything. And I've also grabbed the chat. So really appreciate it. And
Do you have any next step to do, action items, whatever?
I think I'll summarize that on the list. I think there are some specific things that came out of here that we want to highlight, and I think it'd be worth it to kind of get some PRs on that. So how about I'll summarize kind of some of the concrete things that we could add and try to write down or research or document, and we could try to take action items and divvy up that work based on who has time for what. Make sense?
Sounds good.
All right. Thanks, everyone.
Thank you.
Thanks. Bye.
Bye.